If you're like most people, you aren't very familiar with how clean water comes into your home and how dirty water leaves. The Lewiston Auburn Water Pollution Control Authority, or LAPCA, is a wastewater treatment plant for the cities of Lewiston and Auburn. Wastewater is collected from homes, schools, businesses, and industrial facilities and transported in a series of pipes, known as a collection system, to the wastewater treatment plant. Additionally, septic haulers use trucks to carry waste from septic tanks in surrounding communities. At LAPCA, harmful microorganisms and other kinds of pollution are removed from the wastewater so that it can be discharged safely into the Androscoggin River. Did you know that there is no such thing as new water? That's right. All of the water on Earth is the same water that has been here since the beginning of time. Earth's water is always in movement, and the natural water cycle describes the continuous movement of water on, above, and below the surface of the Earth. Water is always changing states between liquid, vapor, and ice. The importance of how we care for and treat the water of planet Earth takes on a greater significance when we think of the saying, "We all live downstream." Another way of looking at it is the water that goes down your sewer pipe today is the water you will drink tomorrow. Of course, the water cycle is nature's way of cleaning used water over time so that it is good, clean, and drinkable. How did it come to pass that the Androscoggin River was once one of the top 10 most polluted rivers in North America? The answer lies more in quantity than anything else. The waste from a few people is as natural to the river as is the waste from a bear or a deer. In small quantities, a large river such as the Androscoggin is well equipped to deal with water through normal, natural processes such as aeration provided by waterfalls and rapids, settling of solids in deep pockets and pools, and biological removal through native bacteria, larvae, fish, and aquatic plants. The problems start when humans discharge too much waste from homes, mills, schools, and even runoff from parking lots. In short, the volume and strength of the waste generated from so many people living along the Androscoggin River got to the point where the natural processes used by nature became overwhelmed, and a polluted, foul-smelling river became the result. Even before Maine's own Senator, Edmund Muskie, proposed the landmark legislation that became the Clean Water Act of 1972, Lewiston and Auburn came together to create LAPCA. By building one wastewater treatment plant instead of two separate ones, the Twin Cities saved millions of dollars and embarked upon a cooperative approach to serving the people of Androscoggin County and cleaning up a truly magnificent river. Like most other city and town treatment plants that are funded by grants and loans established in the Clean Water Act, LAPCA was mainly designed to treat domestic sewage only. However, the treatment plant also receives and treats wastewater from industrial, non-domestic users. As partners in the National Pretreatment Program, LAPCA's responsibilities include finding and controlling dischargers from all industrial users in Lewiston or Auburn that might cause problems in collection or treatment, or who are regulated by the federal government as categorical dischargers. To do this, a permit process was developed to assign rules, regulations, and local limits on all pollutants to protect our sewer workers, keep sewers from overflowing, protect the biological treatment processes, ensure the safety and quality of our compost and other biosolids, and help keep the Androscoggin River a safe place to fish and swim. Permitted industrial users are inspected annually and samples of their wastewater collected and tested to make sure they are following the discharge rules and complying with local limits and any federal categorical limits on pollutants. Industrial users with permits must also regularly sample their own wastewater to make sure they are meeting limits, and they must send reports on their compliance status to LAPCA's pretreatment coordinator at least twice per year. LAPCA has been in operation since 1974 as a wastewater treatment plant. It services over 35,000 domestic users, 23 significant industrial users, and 26 surrounding communities from which septic and holding waste is received. The treatment plant is designed to handle an instantaneous flow of 14.2 million gallons per day, but by permit has to treat a maximum of 32 million gallons per day before bypassing. Originally, the sewers in Lewiston and Auburn carried large quantities of stormwater to the treatment plant in combined sewers. After all, the pipes that had been placed beneath the two cities originally went straight to the river, and there was no need for separate sanitary sewers and stormwater sewers. Because the treatment plant can only process about 32 million gallons per day as a peak flow rate, diluted sewage has been bypassed to the river without treatment. These combined sewer overflows, or CSOs, have been greatly reduced as a result of the millions of dollars that have been spent by both cities to install new separate sewers. Once wastewater arrives at Lopka, preliminary treatment involves the removal of large materials such as rocks, twigs, and various trash items. This material is removed by mechanical bar screens, washed, and then disposed of. Baby wipes, rags, sanitary products, and other non-dispersible items frequently cause problems for pumps and screens. These problems are not only expensive to fix, but they can pose safety threats to the operators who must repair them. The only item that should ever be flushed is toilet paper. All other items should be disposed of in the trash. After large debris is screened, the water moves on to grit removal. Here, sand and other heavy debris is removed and landfilled. Unfortunately, the grit cannot be reclaimed due to it containing dangerous trash items such as needles and razor blades. After grit removal, the wastewater goes through primary treatment. Here, heavy solids settle to the bottom as primary sludge, and some fats, oils, and greases float to the top. The settled primary solids are pumped to the primary thickeners for later solids processing, and the floating fats, oils, and greases are skimmed off the top and transported to landfill. Some grease from soaps and dishwashing is okay, but large amounts of heavy grease and oil can cause sewers to back up into houses or even back up on or under the street. You can be a great help by disposing of cooking grease in the trash instead of putting it down the drain. Up to this point, the treatment process has been mainly physical separation. During secondary treatment, the water travels into the aeration basins to be treated biologically with naturally occurring bacteria and microorganisms that use the organic waste as a food source and break it down into carbon dioxide, water, and inorganic compounds. The microorganisms reproduce and also die, so they are monitored and some are removed from the system to ensure there is always a healthy and thriving population to treat the waste. This solid waste product removed is called activated sludge. In the aeration basin, desired bacteria are selected for by adding oxygen and by avoiding conditions that favor the growth of undesired organisms. These conditions include low nutrients, typically phosphorus, septic or low oxygen conditions, and an unbalanced food-to-mass ratio, with food being what is coming into the basins and mass being the amount of organisms present and ready to metabolize the food. The goal is to prevent too many undesired microorganisms from growing because they can negatively affect treatment. For example, filamentous bacteria can cause significant problems during solid settling, which is the next step in the treatment process. In the secondary clarifiers, there is no aeration to keep the solids in suspension. In this still environment, the activated sludge separates from the water by settling to the bottom. Some of the activated sludge is removed and stored for later solids handling, but some is returned back to the aeration basin because the microorganisms are still viable and able to keep treating the incoming waste. During their time in the clarifiers, the microorganisms do not have any new food, so when they are returned to the aeration basin, they are essentially starving and very ready to keep metabolizing the incoming waste. When the solids settle in the clarifier, the clean water above flows out over weirs and continues its journey to the river. At this point, the water is now called clarifier effluent, and it is much cleaner than when it came into the treatment process. The water has one more stop to make before it goes into the river. In the final basin, it undergoes disinfection from mid-May to the end of September. Disinfection is achieved by applying sodium hypochlorite, which is essentially a strong liquid bleach. Since bleach is toxic, the water is dechlorinated with sodium bisulfite before being discharged into the Androscoggin River. The reason for seasonal chlorination is 1. Biological activity slows down at colder temperatures, making any remaining microorganisms not as able to survive and reproduce. And 2, there's much less recreational use of the river during colder months. People are not as likely to be boating or fishing. The water, now called final effluent, leaves the treatment plant and enters the Androscoggin River. At minimum, 85% of the total suspended solids and oxygen demand have been removed. Now we'll visit the laboratory to learn about the testing done at LAPCA. The laboratory staff is responsible for conducting many tests to ensure LAPCA is providing quality treatment. The final effluent being discharged to the river must meet compliance standards. The Maine Department of Environmental Protection sets limits for certain parameters and assigns those limits as part of a Maine Pollutant Discharge and Elimination System, or MIPDES permit. Let's take a look at some of the testing done in the lab. Total residual chlorine testing is done to ensure that enough chlorine is being applied to achieve adequate disinfection, and also to confirm that proper dechlorination is happening and high levels of chlorine are not being discharged into the river. The typical chlorine level for disinfection might be 1 milligram per liter in the final basin, but the permit limit for what can be discharged is 0.24 milligrams per liter. E. coli is a member of the fecal coliform group of bacteria, meaning that it is found in the intestinal tracts of warm-blooded animals. While many strains are generally harmless, they do live under the same conditions that human pathogens live. Since it is not practical to test for every possible pathogen, E. coli is used because it is an easily detectable indicator organism. E. coli has been shown to be a better predictor of the potential for impacts to human health from exposure to waste effluent and surface waters which contain wastewater effluent. The assumption is that if the indicator organism is killed, other possible pathogens have also been killed during effluent disinfection. LAPCA's E. coli permit limit is 949 colony-forming units, or CFUs, per 100 milliliters of effluent, but the concentration being discharged is typically much lower than that. Another important test is called total suspended solids, or TSS, which is a measure of the non-filterable solids in water. Water is passed through a filter, then the amount trapped is weighed and a solid's concentration is calculated. TSS can include a wide variety of material, such as dirt, decaying plant and animal matter, industrial wastes, and sewage. High concentrations of suspended solids can cause many problems for river health and aquatic life, so reducing them as much as possible is very important. From the time wastewater enters the treatment plant to the time it leaves, the level of solids must have been reduced by at least 85%. The numerical permit limit is 50 milligrams per liter daily maximum. The solids entering from Lewiston and Auburn can average 200 to 500 milligrams per liter. This is reduced to roughly 100 to 150 milligrams per liter after primary treatment, and typically less than 20 milligrams per liter will be discharged into the river. These values can change during atypical situations, such as a major rain event, when the treatment plant can become hydraulically overloaded. Biochemical oxygen demand, or BOD, is the measure of the amount of dissolved oxygen that must be present in water in order for microorganisms to decompose the organic matter present in the water. It can be used as a measure of the degree of pollution in wastewater because the higher the oxygen demand, the greater impact the effluent might have on the receiving water. Similar to total suspended solids, the oxygen demand must be reduced by a minimum of 85% from the time the water enters the treatment plant to the time it is discharged to the river. The numerical permit limit for this is also 50 milligrams per liter daily maximum, though LOPCA routinely discharges 20 milligrams per liter or less of oxygen demand to the river. The test that truly shows how clean the final effluent is called the whole effluent toxicity test. In this test, various concentrations of effluent in river water are used to determine the acute and chronic effects on living organisms. The survivability and reproducibility of water fleas and their survivability and weight gain of brook trout is analyzed. Results have actually shown that the organisms can fare better in 100% effluent than in 100% river water, indicating that the water being discharged from LOPCA is actually cleaner than the water existing in the river. The lab also does daily process control testing to monitor the water treatment. These tests are not required, but they help make sure everything is operating properly and signal when adjustments need to be made. Now that you know where the water goes, we have to go back and review how the solids are treated. If you remember, there is primary sludge that settles out in the primary clarifiers and activated sludge that settles out in the secondary clarifiers. Primary gravity thickeners allow primary sludge to settle and compact. The thickened sludge is withdrawn from the bottom of the tank and is fed to the anaerobic digesters. The water flows over weirs and is returned to the beginning of the treatment plant just before the bar screens. Gravity belt thickeners, or GBTs, are machines that are used to pre-thicken activated sludge, or remove water content, before introducing the sludge into the anaerobic digesters. The goal is to remove as much water as possible so that more degradable solids can be fed to the digesters. The process consists of mixing polymer into the activated sludge stream, thus allowing sludge to clump together and release water. The released water is drained through the belt of the machine and sent back to the beginning of the treatment plant. The now thickened sludge is transferred via progressive cavity pumps into holding tanks. It is from these storage tanks that the sludge is transferred into the digester. At the end of 2012, LOPCA became the first wastewater treatment facility in the state of Maine to construct anaerobic digesters. This extra step in the treatment process was chosen because 1. It reduces the amount of solids that need to be dewatered and land applied or composted, and 2. Creates a methane-rich biogas which can be converted to energy, providing significant financial savings. The digesters have a combined capacity of 1.38 million gallons. They are mesophilic, which means they are maintained at approximately 97 degrees Fahrenheit. The primary sludge and activated sludge from earlier in the treatment process are fed into the anaerobic digesters. High organic strength feedstocks, such as yogurt whey and food waste, are trucked in by various companies and are also fed to the digesters. Within the digesters, different groups of bacteria, called anaerobic bacteria, metabolize the sludges and feedstocks, creating a more stable solid waste product and biogas. Biogas and digested sludge are stored prior to subsequent processing. The gas storage capacity is 33,000 cubic feet, and the digested sludge storage capacity is 168,000 gallons. Before the biogas can be used, it is treated by filtration through iron-impregnated wood chips to remove impurities such as moisture and hydrogen sulfide. The biogas is approximately 65% methane and is used as a fuel in engines to produce electricity, or is used in boilers to produce hot water. The hot water produced by the engine cooling jackets or boilers is used to keep the digesters at the correct temperature. Reciprocating engines were chosen over microturbines due to size, ability to handle somewhat dirtier gas, and maintenance needs. When the amount of gas produced exceeds the rate at which it can be used, plus the storage capacity available, it is flared off to the atmosphere. From a financial standpoint, the anaerobic digestion upgrade has been a success. The total project cost was $15.5 million. Initial estimates predicted an annual savings of $600,000 per year, but recalculation has shown that the process is currently saving LOPCA approximately $1 million per year. Belt filter presses are the machines that are used to dewater solids that have been anaerobically digested. They use similar technology as gravity belt thickeners, but in addition to gravity draining, they remove water from the polymer-conditioned sludge by applying a progressive squeeze on the sludge between two belts, which results in a much drier sludge comparing to what you would get from the gravity belt thickeners. On average, LOPCA can accomplish approximately 13% total solids from the digested sludge. This is fair, but not as high as what newer technology can provide. In late 2015, LOPCA will undergo an upgrade to screw auger presses, which are expected to increase solids dryness. Once pressed, the solids are transferred by conveyor belt into a truck to be delivered to local farms or transported to the compost facility. After being pressed, the solids are referred to as biosolids. The biosolids are either transported to farms to be directly land applied as Class B biosolids for growing hay and corn for cattle, or they are brought to the compost facility for further processing into Class A biosolids. The compost facility has been in operation since 1993. Biosolids from LOPCA and sometimes other wastewater treatment plants is trucked in. Here, the solids go from a mud pie consistency that was seen on the belt filter presses to a more soil-like form that is used for flower and vegetable gardens, landscaping, golf courses, and construction projects. The compost facility receives about 70 wet tons of biosolids per day, 5 days a week. Here, the biosolids are converted to Class A compost called Maine Grow that is sold to contractors, landscapers, and the general public. Compost is composed of biosolids, wood amendment, and recycled compost, which is used as an inoculant. A normal batch is mixed using a layering method of these three components. The layers are turned and fluffed with a front loader until well mixed. This process is done 3 to 4 times until the bin is full and ready to be turned for the day. After the active composting period, the material looks and feels much like peat moss or leaf litter, but it must be cured for a minimum of 30 days prior to unrestricted sale. Biosolid samples are tested monthly for heavy metals. Additional testing is done for parameters such as pesticides and polychlorinated biphenyls, or PCBs. Copies of the regulations and all biosolids analysis records are available to the public at LOPCA or on the website at lopca.org. LOPCA employs 18 treatment plant employees and 3 compost facility technicians. The treatment plant is staffed between 6 a.m. and 4 p.m. 7 days a week, 363 days per year. At times when the treatment plant is not staffed, there is always an operator on call who will respond if there is a situation that needs attention. Being a water quality professional is a career that provides good pay and benefits, but also creates a great deal of pride in environmental stewardship. Thank you for visiting LAPCA and learning about what it takes to treat wastewater. If you have any questions, please do not hesitate to contact us.